So it's mid-October here in Northeast Ohio. It's 8:30 in the morning and it's 43 degrees outside. So today I'm going to heat my cabin with solar power only, and I'm going to measure how long it takes. I want to get started before the sun hits my solar panels. Here, let me show you what that looks like. So currently they're completely in the shade. Okay, and if you look over my shoulder here towards the east, this is the sunrise. So it'll probably be an hour or so before I get sunshine on these solar panels, and they're gonna put out wattage like crazy again. So let's see what the temperature is inside the cabin. So temperature inside the cabin, currently I'm using one of these cooking thermometers. That's all I have. It's currently 48.6 degrees. So that's good. So let's get this cabin up to 68 or 70 with my split unit. Let me turn the inverter on. And let's run a baseline to see what my power consumption is. Yeah, so I just converted the system over yesterday to 48 volts, and right now my baseline is 17 watts. So the battery's at a pretty low state of charge at 52 volts right now. Yeah, we are currently drawing 17 watts and the batteries are sitting at 52.6 volts. So the 17 watts power consumption comes mainly from my cell phone booster here. I also have a little power strip, you know, USB kind of power strip. And then also my TV has a small idle consumption, so all of this together puts out the 17 watt baseline here. So let's turn the heat on. All right, system is coming on. Let's watch the power consumption. Yeah, let me fire up the app here, see what we are drawing here. So 405, 417. So this system is coming up slowly, and currently it's drawing about 417, 443 watts. So it's early in the morning and my charge controller is only putting out about 23 watts of solar power. So let me see if I can figure out the state of charge of this thing. So currently I'm sitting at 51.8 volts and state of charge is 43%. 48 volt system. Yeah, so here the power consumption is increasing to about 600 watts as the system boots up, and the charge controller is still just dingling around at 28 watts. So 10 minutes into it, we are drawing 612 watts, and the solar panels are putting out like 23-ish or so watts, 54 degrees. Okay. So I'm outside here in front of the heat exchanger, and the way these split units work is the refrigerant inside the system is compressed. It's going through these pipes, and the high pressure side ends up on the inside at a heat exchanger. And when you compress gases, the heat is generated and it gets discharged in the cabin. So on the low pressure side, the gas expands and cools down like crazy. And I'm sitting in front of this heat exchanger here right now, and the super cold refrigerant goes through this heat exchanger and it blows the 45-degree air over it, heating it. And then this heated refrigerant then gets compressed again, and it's getting even hotter than it was before, so it ends up in the heat exchanger on the inside of the cabin, exchanges the heat, cools off, and then it repeats the cycle. So pretty amazing. You're not burning fossil fuels, we are not polluting the air. It is very quiet, and it is basically extracting the outside heat that's still there and uses it to heat the cabin. Yeah, I just went upstairs, and of course all the warm air rises, and it's significantly warmer up here than it is downstairs. Of course, I've been in and out of the cabin a few times with the dogs wanting in and out, so it's a real life scenario here. So let's see. Yeah, 20 minutes into it, the inverter draws 630 watts. It's currently 54.3 Fahrenheit in the cabin, and the solar panels are only putting out 30 watts. Yeah, I want to show you something else. So we have a low state of charge battery at less than 50%. So the battery would take any energy these solar panels can generate. And right now we are only generating 30 watts And it's daylight, it's early in the morning, it might be, what is it now, 9 o'clock, not even 9 o'clock yet. And these panels are only putting out 30 watts. Now there's still condensation on these panels, which doesn't help. I don't want to touch them right now. The sun is about to hit these panels in probably another 20 minutes. And my prediction is it's going to put out immediately as the sun hits, probably 600 watts. Supplying electricity to the heater, of course, and then charging the batteries. Yeah, so here you can see where the sun is. So it's coming around here pretty quickly. It's just behind those trees. And give it another 15 or 20 minutes. We're gonna have full sun on these panels. Yeah, here you can see the inverter is drawing 644 watts. And then the solar panels are only providing 39 watts right now. So 30 minutes into the test, the inverter is putting out 640 watts and the solar panels are providing 40 watts. We are currently at 55.2 Fahrenheit in the cabin. So here's the graph, and on the top side, the orange line is the 640 watts that the inverter is drawing currently to heat the cabin. Cabin temperature down there is the other orange line, 55.2 Fahrenheit. And then the green line is the 40 watts of solar coming in. Again, it's very early in the morning, so it'll go up here shortly, but right now we are consuming a lot of battery capacity. Same situation, pretty consistent, 540 watts out, 56 watts in. Yeah, 40 minutes into it, the inverter is putting out 540 watts, and we're getting about 45 watts from the solar panels. Temperature is 55.8 Fahrenheit. 50 minutes into it, inverter is at 660 watts, solar is at 98, cabin temperature 57 Fahrenheit. So inverter is putting out 611 watts, solar panel just jumped up to 600 watts, and the cabin temperature 57.6. So the solar panels just jumped up to 600 watts, generating the same amount that I'm currently consuming, heating the cabin. And I just want to show you what this looks like. It's a very bad angle onto the solar panels. The sun just is peeking behind these clouds here, but it's enough energy to already generate 600 watts. Inverter is generating 681 watts. Solar panels are currently putting out only 88 watts. And cabin temperature is 58.5. Yeah, you can see by the green line, the peak in solar output was really just full sunshine on the panels behind all these clouds. It was just the moment I took the reading. Overall, it's pretty overcast right now, so I'm only getting 88 watts out of the solar panels. 90 minutes into it, the inverter is generating 627 watts, and solar is currently putting out 160 watts. And cabin temperature currently is, let's see, 59 degrees. So 100 minutes into it, the inverter is generating 604 watts. The clouds are slowly moving out of the area here, so the PV input, the solar input is about 250 watts right now. It's up and down quite a bit. Let me see what the cabin temperature is. 60.3. So 110 minutes, the inverter is generating 359 watts. The solar panels are providing 650 watts. Clouds are moving out, which is good. And cabin temperature currently is 61.5 Fahrenheit. So 2 hours into it, the inverter is generating 364 watts and the solar panels are putting out 684 watts. And I'm gonna have full sun for the next 6 hours. So I'll be generating 36, well, almost 4 kilowatt hours, before the sun is gone. So let's see what the cabin temperature is. Hang on, minor details there. 61.7. So 130 minutes into it, the inverter is generating 375 watts. Solar is coming in at 708 watts. So we are generating almost twice as much as we are currently consuming. Let me see what the cabin temperature is. 62.6. Here we go. 140 minutes into it, inverter is generating 330 watts. Solar panels are providing 722 watts. Let me see what the temperature is. 64 degrees. So 150 minutes into it, the inverter is generating 325 watts. Solar panels are providing 727 watts. Let me see what the cabin temperature is. 64.6. Okay, so last measurement, 160 minutes. Inverter is generating 351 watts. Solar is providing 734 watts. Let me see what the cabin temperature is. 64.9. So what I also tracked, of course, was the outside temperature. And if you look at the horizontal axis there, just about at the 90-minute mark, 100-minute mark, we went from 48 Fahrenheit outside temperature to 50 Fahrenheit outside temperature, right? And that's when the orange line, my mini split unit, really dropped from 627 watts down to 359 watts. I mean, it was cut in half. So the minute the outside temperature hit 50 Fahrenheit, the heating cycle out of sudden became much more efficient, right? So the energy consumption jumped back down quite a bit. At the same time, the sun hit my solar panels and I was generating twice the energy I was consuming. I think this data is pretty interesting. So let's look at the cabin temperature here. So it went from 48.6 to basically 64.9, so 65 Fahrenheit within 160 minutes. So is that good? Is that bad? You know, how does that compare to anything else? Well, let's look at it. Yeah, so normalizing this data and looking at the temperature difference. What's the Fahrenheit difference between when we started and when we ended up here at 160 minutes is 16 degrees. You know, so we increased the inside cabin temperature by 16 degrees with electricity that was created by solar energy. So how does that compare to a wood-burning stove? Maybe a Yodel 602 or a Vermont Castings Aspen? Well, let's look at it. I have some data for you. So here's the data we generated with the Vermont Castings Aspen in my small cabin, the yellow line, and we looked at the temperature difference from the starting temperature to the end temperature, and it increased 10 degrees Fahrenheit in 165 minutes. Okay, so then I put in a Yodel 602, which is one of my favorite wood-burning stoves. That's a gray line, and it increased the temperature by 16 point whatever that is. Okay. So that was pretty good. And then the blue line is my mini split on solar. This is what we did today. And the reason I trust this data, I mean, look at the linearity of this blue line. I mean, it's perfectly straight. And the reason it's perfectly straight is because we have the exact same output in kilojoule or watts or whatever you want to measure it in. You know, it's a very linear increase in temperature, and it has the same increase in temperature as a Yodel 602 wood burning stove. It performs better than the Vermont Castings Aspen wood burning stove in heating the cabin. And the Vermont Castings and the Yodel 602, those measurements was taken in my small cabin, which has about 40% less volume of air, and it has about 40% less surface area on the inside. So it's a lot harder to heat my larger cabin, which is the blue line with electricity, than it is the yellow line and the gray line. So this is a comparison. And can you heat your cabin with solar electricity? So in this case and these temperatures, I think you can. I'm not quite sure how sustainable it is, but the data is the data. So that's all I have for you today. So see you guys on the next one.